The FBI laboratory examines and compares a wide variety of physical evidence. This geologic map of the United States is in the petrographic unit. There, experts examine soils, minerals, and materials with mineral components. Surface soils may vary widely in color and texture within very short distances. Thus, a skilled examiner can use soil samples from a suspect's overshoes to place him at the crime scene or to trace his escape route. These soil samples will first be examined microscopically and then washed to separate any mineral particles. The X-ray diffractometer is used in the petrographic unit for analysis of crystalline structures. These are found in many materials with a mineral content, including safe insulation and building materials. Thus, the chart readout of samples found at a crime scene may be compared with X-ray analysis of other samples found in a suspect's clothing. To examine and compare samples of glass, examiners in the petrographic unit use an instrument called a monochromator. Even tiny particles of glass will suffice for samples. They are placed on a special slide with circulating water to maintain an exact and constant temperature. The slide is placed under a microscope. The examiner uses the monochromator to direct light of a specific wavelength through the glass sample. This produces a characteristic color which defines the optical properties of this sample and permits comparison with others. The differential thermal analyzer is also used by examiners in the petrographic unit. It subjects materials to controlled and increasing heat, thus affecting molecular changes. The resultant graphs from soil, building materials, and other petrographic products can be compared for identification. The soil samples, which were scraped from the overshoes, have now been washed to separate out any mineral grains from the clay. The mineral grains are examined under the petrographic microscope. The examiner notes size, shape, and mineral composition as they appear under normal light. He switches to polarized light. The resultant colors aid in identification. After adding to his notes, he rotates the sample, still under polarized light. Now, additional physical characteristics of the mineral grains being examined are revealed. The petrographic examiner completes his findings. Evidence in crimes of violence, such as this bloody garment, is examined by an expert from the Hairs and Fibers Unit, another of several specialized units of the FBI laboratory. He is looking for hairs which may have been transferred during physical contact. After his search is completed, this evidence may go to serology or other laboratory units for further examinations. The technician takes the hair from the container, which has been carefully marked to ensure preservation of the chain of custody. She prepares and mounts it on a labeled slide so that it may be examined, identified, and compared by an examiner who supervises her work. Expert examiners also examine materials containing natural or man-made fibers. Direct comparison can match the torn edges of cloth. More complex chemical techniques can identify the fibrous shred found at a crime scene. The slide-mounted hair from the bloody garment has priority. The examiner's trained eye can learn many things. Is it human hair? Of what race? Animal hair? What family? Was it bleached, dyed, crushed, cut, burned, pulled out? This vital information may help to establish guilt or innocence. These pieces of evidence were sent to the tool mark unit of the FBI laboratory after a safe cracking. Tools and the marks they leave often solve this type of crime. The examiner selects a damaged screwdriver belonging to a suspect and a broken screwdriver tip found at the crime scene. He puts them under his comparison microscope. Later, a photograph will be made showing how they fit together. Other evidence is a sledge and a battered section of the safe door. In the shop, the examiner inspects his evidence under a low-power microscope. First, the piece of metal from the peeled safe door, and then the sledge. The edges of the sledge will have acquired marks and scars during use. If the tool was impounded immediately after the crime, so that no new markings have been acquired, comparison with marks on the safe door can be valuable. He makes impression of the sledge edges on graphited wax. Then, using a microscope, he compares the edge marks with those on the metal of the safe door. He makes another test, striking a soft lead plate with the sledge at the angle indicated on the safe door. Irregularities in the edge of the suspect's sledge show up clearly. Under a comparison microscope, the similarity with sledge marks on the safe door is established. Questioned evidence and known samples will be photographed for possible courtroom use. In a darkened laboratory, an FBI expert uses a high-intensity light to examine the cast of a tire tread. It was made at a crime scene and submitted together with a tire from the suspect's car. The examiner has made an inked impression of a section of the questioned tire matching the cast. He circles on this impression similar irregularities, cuts, worn spots, the impression of embedded foreign objects. His inspection finished and similarities marked, the examiner is ready to write his report. Examiners in the tire tread unit are also experts on the identification and comparison of heel marks. Like the tire tread file, a shoe print file is maintained. Shoe prints can be lifted from a hard surface, or a cast can be made from impressions left in dirt or snow. The examiner compares irregularities in the cast with suspects' tires or shoes. Specialized evidential examinations like these are some of the services offered without charge to any law enforcement agency by the FBI laboratory.